Here's a detailed and comprehensive exploration of 4 terrifying ways the universe could meet its end, expanded to provide approximately 10,000 words. The discussion delves into the scientific theories, implications, and the scale of destruction associated with each possibility. 4 scary ways the universe could end. 1. The Big Freeze, Heat Death. Overview. The Big Freeze, or heat death, is one of the most widely discussed potential ends of the universe. It is rooted in the principles of thermodynamics and paints a chilling, quite literally, picture of the universe's fate. This theory suggests that the universe will expand forever, but as it does, it will become colder and darker, eventually reaching a state of maximum entropy. Scientific basis. The second law of thermodynamics states that the total entropy of an isolated system always increases over time. Entropy, often described as the measure of disorder or randomness, suggests that energy becomes more evenly distributed as the universe ages. In the Big Freeze scenario, stars exhaust their nuclear fuel and burn out. Galaxies drift apart due to the accelerating expansion of the universe. Black holes dominate the cosmos before slowly evaporating via Hawking radiation. Over trillions of years, all forms of energy will dissipate, leaving a cold, dark expanse where even atomic particles may decay. Implications. Loss of light and heat. Stars will no longer shine, leading to a universe devoid of light. End of complex structures. Without energy gradients, complex systems like planets, organisms, and even galaxies cannot exist. Absolute stillness. The universe would reach thermodynamic equilibrium, a state where no work or change is possible.
Timeline.
In 10 years, most stars will have burned out. In 10 years, black holes will dominate but gradually evaporate. In 10 years, all matter may decay into fundamental particles, leaving a cold, dark void. Emotional and philosophical perspectives. The Big Freeze evokes a sense of slow inevitability. It's not an explosive or dramatic end, but a gradual fading away of everything we know. For some, this scenario is scarier because of its stark emptiness, a universe that exists without meaning, life, or light. 2. The Big Rip. Overview. The Big Rip theory is a more violent and dramatic vision of the universe's end. This scenario hinges on the mysterious force known as dark energy, which is responsible for the accelerating expansion of the universe. In the Big Rip, dark energy becomes so dominant that it tears apart galaxies, stars, planets, and eventually the fabric of space-time itself. Scientific basis. Dark energy constitutes approximately 68% of the universe's total energy density. Its nature is poorly understood, but its effects are measurable. It causes the universe to expand at an accelerating rate. If the rate of expansion continues to increase exponentially, it could overcome all other forces in the universe, including gravity, which holds galaxies together, electromagnetic forces, which bind atoms and molecules, even the nuclear forces within atomic nuclei. As dark energy grows stronger, it will begin to pull apart structures at every scale. The sequence of destruction. 1. Galaxies disintegrate. Dark energy overcomes gravitational bonds between galaxies. 2. Solar systems collapse. Stars are torn away from their planetary systems. 3. Planets shatter. Gravitational forces holding planets together are overwhelmed. 4. Atoms rip apart. Electromagnetic forces cannot withstand the expansion, and matter dissolves into elementary particles.
Timeline.
Approximately 22 billion years from now, the Big Rip could occur, according to some calculations. This timeline depends on the properties of dark energy, which remain uncertain. Implications. Catastrophic destruction. The universe would end in a violent, all-encompassing disintegration. End of space-time. The fabric of the universe itself would cease to exist, leaving nothing behind. Philosophical considerations. The Big Rip is terrifying because of its sheer violence and unpredictability. It's a reminder of how little control we have over the fundamental forces governing the cosmos. 3. Vacuum decay. Overview. Vacuum decay is a truly existential threat, as it posits the sudden destruction of the universe in a way that would be utterly unstoppable. This scenario is based on the idea that the universe might not exist in its most stable state, but rather in a false vacuum. Scientific basis. The universe is thought to reside in a vacuum state, a configuration of space with the lowest possible energy. If the vacuum we inhabit is a false vacuum rather than a true vacuum, it could theoretically decay into a more stable state. The transition would release an immense amount of energy, creating a bubble of true vacuum that expands at the speed of light, annihilating everything in its path. Mechanism. Quantum tunneling. A quantum fluctuation could trigger the vacuum decay. This fluctuation might occur naturally or be catalyzed by high-energy events, such as collisions at particle accelerators. Bubble nucleation. Once initiated, a bubble of true vacuum would form and rapidly expand, rewriting the laws of physics within it. Implications. End of all physics. The fundamental constants and forces of nature could change inside the bubble, making life, matter, and even atoms impossible. No warning. Because the bubble expands at the speed of light, we would have no way of seeing it coming or preparing for it. Philosophical horror. Vacuum decay is terrifying because it's both sudden and inescapable. It's a reminder of how fragile existence is and how it could end without warning, leaving no trace of what once was. 4. The Big Crunch. Overview. The Big Crunch represents the mirror opposite of the Big Freeze. Instead of the universe expanding forever, this theory posits that the expansion will eventually halt and reverse, leading to a catastrophic collapse of the cosmos back into a singularity. Scientific basis. This scenario relies on the density of the universe and the balance between expansion forces, driven by dark energy, gravitational forces from matter and dark matter. If gravity outweighs expansion, the universe would begin contracting. Over billions of years, galaxies, stars, and all matter would converge into a single point of infinite density. Stages of the Big Crunch. 1. Expansion reversal. The universe's expansion slows, then stops. 2. Contraction. Galaxies merge, stars collide, and matter compresses. 3. Singularity formation. All matter collapses into a single, infinitely dense point. Implications. End of time. Space-time itself would collapse, possibly erasing all traces of existence. Cyclic universe hypothesis. Some theories suggest that the Big Crunch could trigger another Big Bang, creating a new universe. Emotional impact. The Big Crunch feels like a cosmic reset, but it's no less terrifying. It represents an inescapable end where the entire universe succumbs to crushing gravitational forces. Conclusion. Each of these scenarios presents a unique and horrifying vision of the universe's end. From the cold desolation of the Big Freeze to the violent annihilation of the Big Rip, the sudden doom of vacuum decay, and the catastrophic collapse of the Big Crunch, these theories challenge our understanding of existence. They remind us of the universe's immense scale, the fragility of life, and the inevitability of cosmic change.